Dear physics aspirants, right now I have the physics book and topic will be electromagnetic web, and here you will see the Clerk, Maxwell. James Clerk Maxwell, 1831-1897, born in Edinburgh, Scotland, was among the greatest physicists of the 19th century and derived the thermal velocity distribution of molecules in a gas and was among the first to obtain reliable estimates of molecular parameters from measurable quantities like the viscosity, etc. Maxwell's greatest achievement was the unification of the laws of viscosity, etc. Maxwell's greatest achievement was the unification of the laws of electricity and magnetism discovered by the Coulombs of Oersted, Ampere, and Faraday into a consistent set of equations now called the Maxwell's equations. From these he arrived at the most important conclusion that the light is an electromagnetic web. Interestingly, Maxwell did not agree with the idea strongly suggested by the Faraday's law of electrolysis, that electricity was particulate in nature. Before going to the introduction, you will see here the figure 8.1, a parallel plate capacitor C and a part of the circuit through which a time dependent on current and T flows a loop of radius, and to determine the magnetic field at a point P on the loop at post B number, a port-shaped surface passing through interior between the capacitor plates and with a loop shown in the in A and its rim, you will see here, and teflon shaped surface with the circular loop as its rim and a flat circular bottom as between the capacitor plates. The arrows shows uniform electric field between the capacitor plates. You will see here the description, because now I would like to go with the introduction of electromagnetic web. Chapter is here, chapter 8 of the physics NCERT book of +2 level. When you go, then you will see the electromagnetic webs. Introduction is here, that in chapter 4 we have learned an electric current produces magnetic field, and magnetic field that are two current carrying wires exert in magnetic force on each other. Further, in chapter 6 we have seen that a magnetic field changing with time gives rise to an electric field. Is the converse also true? Does an electric field changing with time give rise to the magnetic field? James Clerk Maxwell, time is given here, argued that this was indeed the case. Not only an electric current but also a time varying electric field generates magnetic field. While applying the Ampere circuital law to find magnetic field at a point outside a capacitor connected to a time varying current, Maxwell noticed an inconsistency in the Ampere circuital law. He suggested that the existence of an additional current, called by him the displacement current, to remove this inconsistency. Maxwell formulated a set of questions involving electric and magnetic fields and their sources, charge and current densities. These equations are known as the Maxwell equations, together with the Lorentz force formula, chapter 4 of the NCERT book. They mathematically express all the basic laws of electromagnetism. The most important prediction to emerge the Maxwell's equations is the existence of electromagnetic waves, which are occupied time varying electric and magnetic fields and propagate in space. The speed of the waves, according to these equations, turned out to be very close to the speed of light, 3 into 10 to the power 8 meter per second, obtained from the optical measurements. This led to the remarkable conclusion of light electromagnetic wave. Maxwell's work thus unified the domain of electricity. Magnetism, like the Hertz in 1885, experimentally demonstrated the existence of electromagnetic waves. Its technological use of the Marconi and other led to the due course in the revolution of the communication that we are witnessing today. So you will see here the Marconi. In this chapter, we first discuss the need for displacement current and its consequences. Then we present a descriptive account of the electromagnetic waves, the broad spectrum of the electromagnetic waves stretching from the here we will assemble alpha, beta, gamma rays. Gamma is 12 wavelengths, approximate 10 to the power minus 12 meter to long. Radio waves, wavelength 10 to the power 6 meter, is described. How the electromagnetic waves are sent and received for communication is discussed in chapter 15. So we will see in next time displacement current. It will provide you the information regarding the electromagnetic wave. We will see a lot more of this topic. Till then, thank you. Thanks for watching the video. Thank you.